projectile motion. In case if you might be knowing something from before, so it will get boring. So I will ask you, tell me the thing that you have traveled with, that thing I will discuss first. So in case of a projectile thrown from the ground level, and if we throw it with speed u at an angle theta, so all of you can find time of flight. No confusion with that. If yes, you tell me. You can find range. You can find maximum height. You can find condition for range, condition for maximum range, and what will be the maximum range. Can you find the angle made by velocity vector, or maybe can you determine the velocity vector at any given time t? Can you find the angle made by velocity vector at any time t? So tell me, among these things, which part is having trouble, Santosh? Because you were there in that projectile motion phase 3 class, no? Which I did not took. So Karthik, and you have done this thing before also. It could become boring for you, maybe. If in case someone knows from before, same thing if I repeat, is going to be boring, no? So time of flight, range, maximum height, condition for maximum range, velocity at time t, angle made by the velocity vector at any time t. No confusion in any of this, no? Okay then.
So
Just tell me.
I was not able to understand the translation motion of accelerated bodies.
Okay, okay, let's see. So how to draw normal contact force, no problem. You understood that.
Yeah, sir.
And how to draw string tension at any point, you understood that, no?
Yes, sir. I was present on that day.
Okay, okay. No, no. After that also we discussed things based on these things. It was not
Oh,
limited to that things only. Okay, how to apply F equals ma in some case when object is undergoing acceleration. That is what you have trouble with, no? Correct?
yes, sir.
See, net force acting on an object we can write down as mass times acceleration, no? So in
Yes,
case if
sir.
we think in terms of the components, so I can write like this also, net force in the x direction will be mass times acceleration along x. Net force in y direction will be mass times acceleration along y. Same way, net force in any direction, it could be any direction, will be mass times acceleration along that direction. So last class we have discussed something like ideal spring also. Okay. That much will not be coming in the test, but still,
Mm.
next test it will come, no?
Yeah, sir.
So those
Mm.
who are here for projectile motion solve this question. So till I discuss this thing, the question is find the angle between initial and final velocity vector when range is maximum and we are throwing the projectile with the speed u at an angle theta from ground level. This question you solve first. Next question that you solve in case if you know something from before. So if I'm throwing a projectile with a speed u at an angle theta from the horizontal like this at height h above the ground. So things that you have to find is first find the final speed. Next thing you find angle made by final velocity vector. What is going to be final velocity vector? The the vector final velocity will be the velocity the one with which it is going to strike the ground. So find the angle made by the final velocity vector with horizontal when it strikes the ground. Find time of flight and D, find range. So when we throw a projectile from some height, h above the ground with speed u at an angle theta, find out A, B, C, D. So while I discuss something of other chapter with her, you don't waste your time. You try solving these two things. It will take time also in case if you don't know. So let's solve this question. So maybe I will solve this question. I'll discuss the doubt that you have using a question. Something that is called as finding the reading of measuring weighing scale. Weighing scale on is going to be something that you use in like general store to weigh something, no? So
Yes,
this
sir.
is a weighing scale kept on a horizontal platform. And generally the symbol we use is this one. And on top of that a block is placed. So a weighing scale measures the normal contact force that acts on it. So in this case, if suppose if I give you m is equal to 2 kg and g is equal to 10 and find the reading of the weighing scale. So you draw the 3-pi diagram. The way the normal contact force is going to act on the block will be upward. Same normal contact force will be applied on the weighing scale by the block. What else will be acting on the block is mg, no?
Mm.
So this normal contact force is what really you have to find to figure out the reading of this weighing scale. So normal contact force, whatever acts on the weighing scale, same acts on the block applied by the weighing scale. This is the reading of weighing scale. So for finding normal contact force, I will write force equation for this block. What is the acceleration he has? 0. So net force must be 0. It has two forces applied on him, N upward, mg down. So N will be equal to mg. And if I plug the values, the answer that I get is N equals 2 into 10, which is 10 Newton. But options are not like that. Suppose options are 3 kg, 2 kg, etc. Then what to do? So the reading in kg, or maybe I'll say kg weight, is going to be equal to reading in Newton divided by the magnitude of the acceleration due to gravity. Reading in Newton, what we have got it as 20 Newton, no? And
Mm.
what is the value of the g given? That you will consider 20 by 10, so answer will be 2 kg. Now suppose same thing is kept in a move accelerating lift. Suppose if I have a case when the lift is going upward with an acceleration that is equal to 5. And same weighing scale, everything same, just they are placed in this lift. So block is of same mass. Mass is 2 kg and g is given as 10. So in this case, if I ask you find the reading of the weighing scale. So first thing you decide from what frame you will be observing this object to apply laws of motion. Only frame from which we know how to write laws of motion is from ground frame only. So in ground frame lies our observer. And what is the observation he has got for the block? That the block is having acceleration A upwards. Then what is the laws of motion tells us for such case? That net force on it in upward direction is m times a. So to find net force, I must draw the free body diagram. So this block has two forces acted upon him. One, this normal contact force, and this is mg. Normal contact force acts upward, mg acts downward. And the acceleration the block has is a upwards. So basically I have to find vector sum of every force acted upon this object. And it is like a 1D case, no? In 1D motion, what we do, we use plus and minus for directions. So even if it is 2D case, but suppose if I ask you, find the things along x direction or find the force along x direction. So what really you are going to do? In case when we do things for a certain component or for one particular direction only, then plus and minus are used for telling direction, no?
Yes, sir.
Just a moment. Okay, so in this case, the object is having acceleration upward. So if I consider upward as positive, it is more better thing to do. I can take downward as positive, still answer will be same. But if I consider downward positive, then what will be the acceleration vector you will write? Minus a, no? But if I take upward as positive, then acceleration vector will be plus a, no? So we will decide a sign convention. And more interesting direction is upward. More interesting direction is upward. So upward I take it as positive. And using this sign convention, if I ask you what is the acceleration vector will be, plus a. What is the normal contact force vector will be, plus n. And what is the mg vector will be, minus mg, no? And we will write net force by finding out the resultant of every force equals mass times acceleration. So what is the net force will be sum of normal contact force vector and mg vector equals ma vector. So what you get, n minus mg equals ma. So n will be equal to mg plus a. So here what we got reading in Newton, we got it as mg plus a. And what we have to find? Reading in kg. So reading in kg will be reading in Newton divided by the value of the g. And what is the reading in Newton we have got? mg plus a divided by g. I will consider taking g as 10 because given 10. So 2 into 15 divided by 10, and that is going to be 3 kg. So the block actually is of 2 kg, but whatever the effect I will have having a 3 kg, suppose if you hold a 3 kg block in ground frame, then whatever effort you will be applying, same effort you will be applying in holding a 2 kg block in this frame which is accelerating upward with 5. I hope you got the point how to apply F equals ma, and also you got the point how to get the reading in kg. Got it, no?
Yes. Yes, sir.
Suppose same lift, just a second, give me 1 minute. Okay, now suppose same lift, same everything, just that lift is going downward with some acceleration. Everything same. Suppose lift is going down with an acceleration, but that acceleration is less than g. What will happen if acceleration is equal to g or minus g, that we will say? Okay, beginner box 2, question 2. So do one thing in there till you solve this question. Find the reading or find normal contact force. Okay, till I will solve that question. Beginner box 2, which exercise? Laws of motion, projectile motion. Which exercise? Which exercise? We'll open that module.
Sir,
Yes,
sir,
tell me.
in the chapter Newton laws, beginner box 2 and exercise
Okay.
1, question number 4 and 23.
Okay, I'll solve. Just give me a second. Don't have the module, man. Think so. I have the old module. Can you send me the question if possible?
Okay, sir, I'll send.
I have old module. Things will not be same. Yeah. Yeah, I got. There's no problem. I got the module. Doubt. Come. Exercise 1. I'll check once again. Questions. Beginner box 2. Exercise 1. Question number 4 and 23. Exercise 1. Question number 4. Okay. Cynthia, I can check out this question also. Exercise 1.
Okay.
Question number 4. Okay. That which question? Which concept? So net for 0. Yeah, net for 0. Yeah. Just depending upon what is being asked, accordingly we will solve. So maybe do one thing. Exercise 1. Try the last question. Try this question number 16. Okay. Exercise 1, question number 16. Try draw the ABD of the sphere. Exercise no 1 it is. A 2. Exercise 2, last question. Yeah. So they're asking us what happens to the normal contact force acting on the sphere applied by AB and normal contact force. This question, exercise. This question. You have trouble. This question. We have to find what happens to this normal contact force acting on the sphere applied by the AB and BC if we increase the acceleration of the carriage. That is the question. So first job will be to draw the free body diagram and tell me what all forces will act on this sphere since every surface is smooth, only force acting on it by the surfaces will be normal contact force. And what else will act? Gravity, no? So if I consider the surface AB, for AB surface, the contact here is at this place, no? So for that contact, which is the common tangent, this is the common tangent. And to figure out which way normal contact force acts, I will draw up a normal, and this is the common normal. And normal drawn to a spherical thing has to pass through the center. So this red line is the common normal, the one for which is for the surface AB. Now, for the contact that it has with this vertical BC part, which is the common tangent. Common tangent is this BC line only, no? And the common normal will be perpendicular to that. And this is going to be that common normal, which is horizontal. This green line is the common normal for BC, and red line is the common normal of AB. Now, before we draw anything, some angle thing we should check out. This blue line is the vertical line. So tell me what is the angle between the red line and the blue line is. So for that you do this thing, angle between this dotted horizontal line and this line AB is 30 degrees. So this red line is perpendicular to AB, correct? So this red line is perpendicular to AB, correct? And this blue line is perpendicular to the horizontal. So these two lines also must make same angle, that will be 30 degrees. So this angle will be 30 degrees. Now we will draw the free body diagram of this sphere. So this is the blue vertical line. And this is our red normal contact force, the one which is applied by surface AB. And how it will be applied? It will be acting along the common normal to push away this sphere away from AB. So it will be a pushing force acting along the common normal. So, and the line of action of this force, if I extend, has to pass through the center of the sphere, no? Just a moment. Online teaching has different kind of problems. Drawing things and also headache. It's like time consuming. Now, another normal contact force that is acting is applied by BC, and everyone can tell is going to be acting like that. And this is our NBC, and this is our NAB. And what else will be acting? Gravity at the center, no? Like this. Now the thing is, I have to write the force equations. So here also you can think in terms of the components. But which two components we must be thinking in terms of? Two or three? Two components only. Things are happening in one plane. Every force is something which is acting in one plane. Correct? And whenever we take any components, it is something going to be in mutually perpendicular direction. So one direction of interest is horizontal because from the ground frame, what is the observation you will have for this sphere? that it is moving along leftward direction, which is horizontal leftward with an acceleration. So let's check out what all forces it has got along x and y direction. So this angle is going to be 30 degrees. We have seen that. So this will be also 30 degrees, no? You tell me how 30. This one parallel, no? If this blue line is parallel to this blue line. So there's name of corresponding angle, correct? I think so. Name is corresponding angle. Or y corresponding angle name and all you have to know. So this is an AB line, no? Correct? So this blue line is parallel to this blue line. So angle made by this blue line with this one is 30. So this blue line will make what? Same only, no? Angle between two lines. Suppose L1, L2 has angle theta. So what is the angle between L1 parallel and L2 parallel will be? Theta only, no? So we will resolve when AB, it will be having two components. One this, another upward, no? So one NAB component this side will be NAB sine 30. So with whichever direction vector making an angle theta, component along that will be cos of that angle, no? So component of NAB upward is NAB cos 30. So now we have done the resolving, and then we will see each and every direction separately. And we are going to resolve things into this way. Suppose leftward is our positive x and upward is our positive y. So what is the net acceleration the object has along y direction? 0. So what is the net force along y direction will be? 0. So when we think of y direction, just you think of the forces that are along y acting on a point object. What all forces you have along y direction? One is NAB sine theta upward. What sine theta? One is NAB cos 30 upward and NAB and MG acting down. So in order to have net force 0 along the vertical or y direction, what really you will write? NA cos 30, I wrote NA, no? NAB it is, just a moment. NAB cos 30 acting upward and what else acting down is MG acting down. So to have net force 0 along y, NAB cos 30 should be equal to mg. NAB cos 30 is equal to mg. So what NAB is equal to mg by cos 30. Now upon changing the acceleration A, is it going to affect him? Oh no, there is no term of A. So it is independent of A. So what will happen to it? It remains constant, no? Now check out the x direction. Now what is the observation we have regarding him when we check it out from ground frame? So along the x direction, the acceleration it has is, come on, the doubt. Which question? Once again. Just I'm in between something. Acceleration along x direction is A. So net force along x direction will be MA. So what all forces it has got along x direction? So NAB is leftward, and sorry, NBC is leftward. I've drawn it like green, no. So this is our NBC, which is which side? Leftward. So just you think of the forces along horizontal. Two are there. One is NBC, which is leftward. And what else is NAB sine 30 rightward. And the object is having acceleration this side. So this side I will be taking it as positive because whenever we write for one such one component, plus minus used for direction. So vector NBC will be plus NBC. Vector NAB sine 30 will be minus NAB sine 30. And that must be equal to MA, correct? So what I get from here that NBC is equal to NAB by 2 plus MA. So now NAB, this term is constant, okay? But upon increasing A, what really you will find? NBC increases. So now you can check which option is correct. Tell me your doubt. Fifth question.
Yeah.
A ball is reached from top of a tower. The ratio of the work done by the gravity in first second, second, and the third second. See, the object is dropped from some height h, but with what speed it is dropped from? 0. So the ratio of the work done in the first second. So in 1 second, what is the speed it is going to get? V equals u plus at. And only force that is doing work is gravity. So initial kinetic energy, 0. Once it reaches some height in 1 second, the speed it acquires v, and maybe downward I will take positive u0. So what is the speed will be after 1 second? Gt. So work done by gravity is the only work done. So net work done is equal to change in kinetic energy. So it will be half mv square minus 0, initial 0, no? So work done in time t will be equal to half m into g square t square. So work done in first second and second like that. So what is the speed that it is going to get after again 1 second? You can find out. So second means time interval will be starting from 1 and ending at 2. So in that much time, what is the speed it is having? So here speed, next speed here you can find. Take the difference. That will give you work done. Take ratios, you will find the answer. Clear? No? That's all. Okay, what was your doubt, man? So your doubt got cleared, no? This thing. So net force 0 along x. Don't tell me. Next doubt that he has asked. Let me check once. Question number 23. It's size 1 only, no? Okay, 23. That's all. Check out this question also. Man. So they're asking us to figure out the acceleration of each block just after cutting one of the spring. So question number 22, those who have not tried, okay, I'll ask you to try now only, man. So whichever spring is cut, suppose first I'll solve 22, okay, Subramaniam, because there's a continuity here. If they're asking for 23, I'll solve 22 also. So in question number 22, which is spring is cut, let's check it out now. Initially, both the blocks are at rest. And then we have to find the acceleration of A and B just after cutting the spring 2. So just after cutting the spring 2, the tension in the spring 2 will disappear. And force due to the spring 1 will be same as before cutting or will be different. Same only because for the spring force to be something, spring extension must be something, correct? And for the spring length to change, it will take some time, but we are giving him 0 time. Just after cutting 2, the extension of the spring 1, whatever it was before, same it will be, no? So just after, because so yeah, correct. So yeah, correct. Its length will change, but it's for length to change, I must give him some time. No, suppose at t equals to 0, I'm cutting this spring to. At t equals to 0, the block B present here. And then I'm asking you where the block B will be at time t equals 0.0000001 second. Same place only. So block B remains there only. So how much the spring 1 will be having any length change? Nothing. Block A beam goes up, then it changes. Block B goes down, then changes, but it's not going to move at all. So what is the length of the spring 1 will be before cutting the spring 2 and just after cutting the spring 2? Same only. Same length the spring has, means force due to the spring will be correct what it is, whatever it was before, no? So just after cutting 2, then the tension in spring 2 will become 0, correct? And but the tension in the spring 1 will be same as whatever it was just before cutting, no? Correct. It means basically I have to figure out what is the spring force in the spring 1 will be just before cutting spring 2, correct? So what I will do, maybe solve it faster. I will consider A and B as our system. Why we can do such thing? Because just before cutting, A and B both for having same acceleration 0, 0. Maybe I will take A and B as our system. You can take them separately also, not a problem at all. Maybe I'll do it like this first. Then when we do such thing, we just have to draw the forces which are external force. So force applied on the spring B by the spring number 1, force applied on the B by the spring 1 will be upward. Suppose I call it as F1. The force in this between A and B, we would care about that. It is internal force. What else is going to be an external force? That will be the net pull of gravity down now. So, and one will be 2 mg, other is mg, so 3 mg acting down. And correct? Yeah, correct, 2 m and m. And it is what kind of thing this system is doing. Having zero acceleration means net force will be 0. So F1 must be equal to 3 mg. Correct? So now we will draw the free body diagram of A and B just after cutting the spring 2. Just after 2 is cut, drawing the ability of B nothing much no, A nothing much no. Only force that will act on A will be mg, and his mass is how much m. So what is the acceleration A will be having downward, and how much it will be g. And on B, spring force F1 will continue acting same whatever it was before, but his mass is 2m, so 2 mg acting down. And how much F1 is 3 mg. So what is the net force he has upon him? The net force on him is 3 mg minus 2 mg, which is in upward direction. Correct. So I'm asking you, who is more? F1 more, no? F1 is 3 mg. F this is 2 mg. So what is the net force? Mg, no? Correct. The net force is upward, and that is how much? Mg. Correct. And net force will be equal to mass times his acceleration, no? What is the mass he has? 2m, acceleration of p, and mg equals 2m into acceleration of B. So acceleration of B is how much? G by 2, which is force. Now in the next case, spring number 1 is cut. So spring number 1 cut, but spring 2, whatever force was there in spring 2, same it will be there afterwards also. Okay. So maybe I'll take a new page and I will draw the diagram for each of them. Just before cutting the spring, if I ask you to draw the ABD of B, we will draw ABD of every one of them. Okay. Spring 2 also, spring 1 also. And ceiling also. So we'll start from the lower block A. What all forces that are acting on him? One is mg. Before cutting this thing I'm talking about. And somehow it is under equilibrium. Then there must act a force upward, and what it can be. Before cutting, yeah. No, let's see. I'm talking about A's. I'm not talking about A and B together. I'm just drawing. So earlier what I did, I have drawn the ABD of both of them together, no? So mass of the system is how much? 3m. So 3mg. I'm drawing for each of them. So force acting on A block applied by this spring to, they call it as F1. And which way it will be? Upward. And the spring 2 is, suppose F2 it is, the spring 2 is applying a force F2 upward. How much force will act upon him? The one which is going to be applied by the block will be F2 downward, no? And what kind of spring it is? Massless, no? Massless means net force on him must be 0. And he has a F2 acting on him down. How we can have net force 0 on him? Same F2 must act upward. Okay. And same F2 will act on the block. How we are drawing that? Newton's third law, no? So the spring 2 is pulling the block A upward and it's pulling the block B downward, no? Apart from F2, what else will act on the block? 2mg, correct? And it's still it is under equilibrium, and it means the spring which is above him must be applying some force. Let's call it as F1. Same force will be applied on the spring by this block is going to be 1, no? And again, it is massless, so net force on him must be 0. So he is going to be pulled up by ceiling by F1, means the ceiling is going to be pulled down by F1, no? I hope free body diagram is clear to everyone. So this is also a massless spring, so net force on him must be also 0. And it has F1 acting down, so there must come an additional force who will be applying the ceiling. No. Now every object is under equilibrium. If I write for this 2m, net force is going to be 0. So F1 upward must be balancing F2 plus 2mg, correct? Next, so this is for not for A, that is no. Next, I am going to make net force 0 on A. So F2 must be equal to mg, correct? So now from this two, if I ask you from equation number 1 and 2, can you find X1? X1 is equal to how much? 3 mg, no? Same thing we got if I took both of them as one system. How much F1 can change, no? Now in this case, they are telling us that spring 1 is cut. On cutting spring 1, what will happen? F1 force will vanish. F1 force will vanish. F2 will remain same and everything else will remain same. So now we are cutting spring number 1. So spring number 1, for that I'm writing F1. So F1 will become 0, no? So on cutting spring 1, F1 I will make it 0 and F2 will be same. And what F2 is before mg. So this is the diagram I have drawn before, no? This is the diagram for afterwards will be. So F1 0, F2 equals mg, F2 equals mg. So now check out each of the options. What is going to be the acceleration of our object? So net force on B is acting down, no? And how much it is? 3 mg, no? What is the net force on B? 2 mg and mg? 3 mg. His mass is how much? 2m. So 2ma is equal to 3 mg. So what is the acceleration of B? 3g by 2. Which way? Downward. And what really happened? What really will be happening to A? The acceleration of A will be 0. You can see the net force on A just after cutting spring 1 is 0. Now we can check which option is correct. So just after cutting, the acceleration of A is 0. Acceleration of B is 3g by down. 3g by 2 downwards. Clear? So one name clear now?
Clear,
This
sir.
should, okay then. Next tell me beginner box. Beginner
Yes, sir.
box.
Beginner box 2, question number 2.
Beginner box. Question number 2. See the model man. This question, man. In the module.
I shall screenshot, sir.
No, I have module. I have module. Different kind of headache. Stomach. Beginner box one done, no? Easy question. Why you were stuck maybe this moment. From the figure, you have to judge where angle is more or less. Okay, then we can answer it. Easy only. Just from the figure, you make some judgment. So in which of the case the magnitude of the tension will be largest? Okay. Suppose if I take any case, and maybe I draw the free body diagram, maybe this case. So what tension that is going to act, we don't know. Maybe I call it as T1. And you see the point where the strings are attached are lying on same horizontal level. Because of that, if I draw a vertical passing through this point, you can tell no this angle and this angle will be same or different. Will be same only or not? Yes. Now if I ask you to draw the free body diagram of this block, for that I'll be dividing it from here and we'll be dividing it from here. The tension T1 and T2 must be acting like this. This is our T1, this is our, and what else will act? Mg will be acting down. This angle theta, this angle theta. So really they are doing at rest, no? So I will resolve T1, T. Tell me. Normal contact force, another name, normal reaction. Yeah, that is also called as normal reaction. That's what. Net reaction force means resultant of normal contact force and friction. Good. Because this forces acts as if surface is reacting to the thing you are doing to the surface. If surface is rough, you push the surface back, correct? By using your feet. Then only there acts a friction force, no? So don't push the surface back. Friction force will not act. That's why name is also reaction force, no? So component of T1, one will be this side. That will be T1 sine theta. Component of T2, another will be this side. T2 sine theta, correct? Now net force along horizontal should be 0. So T1 sine theta must be equal to T2 sine theta. So T1 should be equal to T2. Let's call it as. So what is the net force that is there in vertically upward direction? One is T1 cos theta, another is T2 cos theta. Now T1, T2 both same. So net force in vertically upward direction is going to be T cos theta, T cos theta, 2T cos theta. And what else is acting? Mg is acting down. So 2T cos theta must be equal to Mg. So T should be equal to Mg by theta. Now you try to answer it. But don't forget, cos theta is a weird function, decreasing function, no? So more the strings are going to be closer, the angle theta will be lesser, correct? The strings are more closer, theta angle will be lesser. Less theta I give, cos theta will be more, no? Cos theta will be more. And where cos theta is present, that cos theta is present in denominator, no? So more the cos theta is, what we can say, denominator is more. Denominator is more, means the entire expression of t will be lesser, no? So in case if I have theta largest, cos theta will be smallest. Cos theta smallest, then tension will be largest. Correct? So in whichever case the spread is more, that you have to judgment which case the spread is more. In a case the spread is more, no? So more spread, tension will be more. Clear, no? Understood, no man?
Okay, sir.
Easy only, no?
Easy only.
This one I'll solve. Okay. This one I'll open it. So again, you do the same exact thing. Angle between two lines, something, angle between their parallel, and angle between their perpendicular will be same. I'll do that still. So this question we have done it in class also. Since he is asking, I'm solving it. Exercise 1, last question. If you find the normal contact force acting at A and B, that is called as normal reaction force also. So whenever we draw a normal, not mistake here, man. I'll draw my own figure. So this angle, I call it as theta 1. This is given as 60 degrees. So one thing is sure that normal contact force will be acting along common normal. So it should be passing through the center, no? So if I draw the common normal, it's dotted purple line, no? And this dotted black line. Tell me, angle between this horizontal and angle between this surface is something theta 1, no? So what is the angle between this vertical dotted black line and this dotted purple line perpendicular to the surface will be how much? Same only. So I will write that thing. Angle between two line A and B is theta. An angle between their perpendiculars will be theta. Angle between their parallels will be theta. Angle between perpendicular to A and parallel to B will be 90 minus theta. Angle between parallel to A and perpendicular to B will be 90 minus theta. So this dotted line is perpendicular to the horizontal and this perpendicular to the surface. The surface and horizontal has theta 1, so this two also will have theta 1, no? Same logic, you tell me, if I draw this dotted line, if I draw this dotted line, this angle will be, if this I consider as theta, this will be theta, this is theta 1, clear, no? After that, easy only. The forces that are going to be acted upon this sphere will be our common normal. Common normal for left side contact is this one, and common normal for the other contact is this one. So we'll draw the free body diagram of this sphere. So one force is this one, suppose N1. What angle N1 is having from the vertical? Theta 1, no? And here I have a force N2. Drawing things takes so much time, man. This is N1. So angle made by N1 with vertical, N1 acts along the common normal, this purple one. They're acting as normal contact force. Both. Yeah. So this angle is given theta 1, which is 60 degrees. So this is 60. And this is N1. And this is N2. So this angle is 30. If I resolve N1, we have two components, one this side, one this way, no? We resolve N2, N2 has one component this side, one component upward. So we have N1, so it is making an angle 60 with something, so component along that is N1 cos 60. And component other one will be N1 sin 60 and sin 30 and cos 30. What else is acting? Mg, no? Make net force 0 along horizontal. So you have two forces, one this side, one this side. Yeah, why? First I'm writing for x horizontal. So rightward I have and sin 30. Leftward we have n1 sin 60. So n2 sin 30 must be equal to n1 sin 60. So n2 equals root 3 n1. And we must have net force 0 along vertical also. So two forces are acting along vertical upward and one mg acting down. So what all things I have in vertical direction? We have n1 cos 60 and n2 cos 30. And we have mg acting down. So n1 cos 60 plus n cos 30 should be equal to mg. And then maybe you can write down n1 cos 60 is n1 by 2. This is 3 and 2 by 2 equals mg. What is n root 3 n1? Is it there? So n1 by 3 n1 will give us 3 n1 by 2 equals mg. Solving it, you will get mg n1 equals mg by and 2 is root 3 n1. So root 3 mg by clear, no? Okay, then anyone having any doubts, man? I thought it will be project. Yeah, I have class. Like in 7:10 I have class. Yeah, doubts then maybe tomorrow my class will get. Tomorrow you go home 7 p.m. I'll take such kind of class online. Join. No. Okay, I thought it I will take projectile backup and this time was used up in doubts only. No problem. Doubts was also important. Okay. Anyone present here any doubts? Tell me when. Okay, that question I gave for projectile you were able to solve or not? We'll solve it fast first, okay? So we have thrown a projectile from some height h and we have to figure out things. So all of you can solve no, this thing or not. Karthik, you know how to find out the time of flight and everything in this case?
Yes, sir.
Okay, then no problem. That means you know I have projectile. Tell me your dot and tell me. So it's how to find area manually, man. Forgot. V2 plot area I have to find. So if I tell you this is FT plot. So and this area you will take positive or not? That same thing. Yeah. So you're finding area manually without using integration. Then clear? Rarely you will do such thing. That's like simple thing. Okay, so finding time of flight, finding initial, final speed, everything, no problem. Good then. Santosh, there no. Mitra, no doubt this in this thing, no. This angle theta. So we will consider this as our x. This is our y. It is going to take some curved path. Will hit here. It will be traveling with something along x, something along y. The velocity along x never changes because acceleration along x is 0. So Vx will be u cos theta. Vy we have to find out. When it will be hitting here, displacement along y direction will be minus h. And displacement along x direction, when it reaches here, is the range, no? Because this much it is the range, and that is the displacement along x. So to find the final speed Vy, we can use this thing Vy square equals Uy square twice of Ay into Sy. Uy will be u sine theta square. Ay is minus g, displacement along y minus h. So Vy square is equal to u square sine square theta plus 2gh. So Vy you can find out. Vy will be root over u square sine square theta plus 2gh. Vx is equal to u cos theta. So total speed is asked. You can do this thing Vx square plus Vy square. If we do that, it is going to become u square plus 2gh. Check that thing on your own. If I ask you find the angle it is going to be having with the horizontal whenever it will hit the ground. So it will be traveling with something along x, something along y, and the net velocity vector will be like that. And suppose it is making an angle alpha. This is Vy, this is Vx. I will shift the arrow of Vy parallel to itself and I will draw it here. And from this triangle, if answer is to be given in terms of tan, so tan alpha will be length of Vy by length of Vx. Vy we know, Vx we know, we can find. In case sine alpha is the thing is to be reported, that will be length of Vy by length of V. And that V also we can find out. Cos alpha, if I have to report, it will be length of Vx by V. Both we know how to find out. Now to find range, I have to find out the time of flight first. So to find time of flight, we will find how much displacement it undergoes whenever it will hit the ground. Sy will be Uyt plus half of Ay into t square. Displacement along y minus h. Uy is u sine theta t. Ay is minus gt square. And that is going to be a quadratic gt square minus of 2u sine theta t minus of 2h is equal to 0. And if you'll find, you will get two roots, one t1, one t2. And you will find one root will be negative, suppose t2 negative and t1 positive. The negative root you will neglect and the positive root will be the time of flight. And the positive root that you will calculate, no, that is something which is going to come equal to this. U sine theta plus root over u square sine square theta. So try solving that quadratic after the class. And the positive root, you will get it this one. And what is u sine theta? Initial speed along y direction. And what is the other term is? Final speed along y direction. And what is g is? Magnitude of the acceleration along y direction. And once you know time of flight, the range will be u cos theta into t. That too you can find out. I hope you got that question. One more question I gave. Find the angle between initial velocity vector and the final velocity vector when range is maximum. You got that thing also? Theta came how much? Pi by 2 only. If not, I will solve it then. Okay. Anyone having any doubts? Maybe some other time I will take projectile backup because some people needed that backup. They are not in class also because they are of weekdays. Some common day I will take when everyone is present. Okay then, so Sindhya, no doubt, no? So go through the class notes and try all the questions. Okay. Projectile motion and up to laws of motion, whatever is like beginner box 1, that much only will come. Okay. Maybe beginner box 2. Just drawing free body diagram, making net force 0. That's all.
Sir,
Okay,
no related motion also.
no relative motion. That is what I've told in the class. No, whatever I've told in the class, that is the final word. Okay. Okay then. Bye everyone. The concept will take time, man. Tomorrow you ask me tomorrow in chemistry practice session. You come because that girl is new. I have to teach her also. I will teach you also together. It can be done. It will take more time. 5 minutes it can't be told. Till then you read the notes, whatever you understand good, or else tomorrow you will understand.
Sir, will you send this recording session?
Yeah, obviously I'll send this recording session. Yeah, why not? That's why I took Zoom session, man, so that I can record it. Today's doubt class, 10th August. So I said it in YouTube because where I will how much storage I will buy, man. Their free storage I can use, but problem is those who are not having premium account. But I have not made it. I don't know. I've not made it. I have not monetized it, so it will not be showing ads also. Okay, then I'll end the class by everyone. Next class I will tell you when it will be. Okay, then bye bye.
Bye, sir. Thank you, sir.
Bye. Tomorrow 5:30. Tomorrow I recorded this thing or not, man? Okay, I recorded. Thank God.